In lesson 2.5, we'll be learning about solving compound inequalities. So what is a compound inequality? It's an inequality formed by joining two inequalities with the word and or the word or. An and inequality is an intersection or overlap of two graphs, so it will be shaded between the points. So how we would write this is we'd have a dot and we'd have a dot and then they're connected. It's shaded between. It's the overlap or intersection. And then an or inequality is the union of two graphs and they're shaded away from each other. How this is going to look, we have a dot, it's shaded one way. We have another dot, it's shaded the other way. All right, to get us used to the idea of two inequalities joining together, we have some word problems so that we can just write it and then we're going to graph it as well. So example 1a, a number is greater than -8. So we have n is greater than -8 and less than or equal to 4. Less than or equal to 4. So it has to be both. How that's going to look on a number line, we have -8, we have 4. It has to be greater than -8 and it has to be less than 4. That's an and. Oh, less than or equal to 4, so that's shaded in. All right, part B, a number is at most 0, meaning less than or equal to 0, or at least 2. So it's at most 0 or it's at least 2, meaning on a number line, 0's here and 2's here. It could be less than or equal to 0. It could be greater than or equal to 2. So that's going to go away from each other. All right, this is where you should pause the video, try C and D on your own, and then check them to see if you got them right. All right, I'm going to solve number C, letter C. A number D is more than 0 and less than 10. Notice the and. So D is greater than 0 and D is less than 10. We draw this on a number line. We have 0, we have 10. It has to be greater than 0 and less than 10. So it has to be between 0 and 10. All right, last one. A number A is fewer than -6 or no less than 3. No less than 3 meaning greater than or equal to, -3. All right, so we're going to set this up on a number line. We have -6, we have -3, and A can be less than -6 or greater than or equal to -3. All right, so when we're solving compound inequalities, specifically and inequalities, you can separate it into two or you can keep it as one. I'll show you, for example, A, how you would solve it if you keep it as one, and then I'll show you, for example, B, what I mean by split it into two different inequalities. So when you solve it as one giant inequality, I see in the middle x minus 2. I know to solve for x, I have to add 2. But the tricky thing with a compound inequality is I have to add 2 to every side, which is now 3 sides. So if I add 2 to get rid of that 2, I have to add 2 to the left and add 2 to the right. So you can keep it as 1 as long as you remember to balance all 3 sides of the inequality. So now I have -4 plus 2, which is -2, is less than x, which is less than 5. That means x is between -2 and 5. So on a number line, I have -2, I have 5. X has to be greater than -2 and less than 5. It's the overlap, it's the in-between. All right, how you would solve this by splitting it into two equations. You take this side as 1 and then you take this side as 1. So we have -3 is less than -2x plus 1. And then the other equation, we have -2x plus 1 is less than or equal to 9. So the helpful thing about splitting it into two is that now you can just worry about two sides again. You don't have to worry about balancing 3 sides of an equation. The tricky thing about splitting it into two is you have to repeat the whole middle twice. All right, so the first side, -3 is less than -2x plus 1. We're going to solve for x, so subtract 1 from both sides. -3 minus 1 is -4, which is less than -2x. Now to get x by itself, I have to divide by -2. And, did you catch it? We divided by a negative, meaning I have to flip the sign. So now I have +2 is greater than x. All right, other side, we subtract 1. -2x is less than or equal to 8. Divide by -2. Flip the sign because we divided by a negative. So now x is greater than or equal to -4. And when we set this up on a number line, even though we split it into 2, it's still going to look the same. So I put -4 and +2. And when I look at the 2 side, it's x is less than 2. 2 is greater than x. So it's going to go towards the 4. It's less than. Then the second one, the right side, x is greater than or equal to -4. Make sure you shade in that or equal to, and it's greater than, so it goes towards the 2. It's an and compound inequality, so we're shading the overlap, the middle. All right, so now we're graphing or inequalities. Really, the or inequalities are just like the regular inequalities, but we have 2 on the same graph. They're pointing in opposite directions. All right, so for part A, we have, just trying to zoom in. For part A, we have 4c plus 3 is less than or equal to -5. We're going to solve for c, so let's subtract 3 from both sides. I have 4c is less than or equal to -8. And now I divide by 4. So I have c is less than or equal to -2. I divided by a positive, so I did not have to flip the sign. And now the second equation, I have c minus 8 is greater than -1. Add 8 to both sides, and I have c is greater than 7. So when we set this up on a number line, our inequalities are going to go away from each other. So c is less than or equal to -2. Make sure you shade in the or equal to, it points to the lesser numbers. And c is greater than 7, it points to the greater numbers. All right, part B, I have 2p plus 1 is less than -7, or 3 minus 2p is less than or equal to -1. So let's solve for p. We're going to subtract 1 from both sides. I have 2p is less than -8, and divide by 2. So I have p is less than -4, or 3 minus 2p is less than or equal to -1. I'm going to start by subtracting 3 from both sides. So I have -2p is less than or equal to -1 minus 3 is -4. Now I divide by -2. Hopefully you caught that. We divided by a negative, which means we're going to flip the sign. So p is greater than or equal to -4 divided by -2 is +2. And we're going to set this up on a number line. I have -4 down here and +2 up here. 0 would be somewhere in the middle there. All right, p is less than -4, so it points to the lesser numbers. Or p is greater than or equal to 2. And there we go. All right, let's wrap it up with some summary questions. What is a compound inequality? A compound inequality is when you join together 2 inequalities with either an and or an or. So how do you solve an and inequality when the inequality is all together? You can either split it into 2, or you have to make sure you do the same thing to all 3 sides. How do you solve an or compound inequality? We're going to solve those just like our regular inequalities. You just have to make sure you graph them both. So how are the graphs of an and inequality different than the graphs of an or inequality? An and is going to point towards each other, and an or is going to go away from each other. So the and is the intersection, the overlap, and the or is the union of the arrows going in opposite directions.